The Philosophy of Assembly with Steve Gibson, and Lou Maresca drops by to give us a guest co-host spot. Coding 101 is next.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Coding 101 is provided by CacheFly at CacheFly.com.
This episode of Coding 101 is brought to you by HipChat Plus. Collaborate, save time, and be more productive with your teams. HipChat Plus is IM, video chat plus file, code, and screen sharing all in one place. Invite your team members and get a free 30-day trial of HipChat Plus at hipchat.com/C101. And by lynda.com. Invest in yourself for 2015. Lynda.com has thousands of courses to help you learn new tech, business, and creative skills. For a free 10-day trial, visit lynda.com/C101. That's LYNDA.com/C101. Welcome to Coding 101. It's the Twitch show where we let you into the wonderful world of the code warrior / monkey. I'm Father Robert Ballecer, the digital Jesuit, and joining me today for a special spot of the show is Lou Maresca. Now, you've seen him before. He's been a code warrior, but today he is our guest co-host. Lou, thank you for doing this.
Hey, thanks, Padre, for having me back. I appreciate it.
Now, we kind of wanted to test this out a little bit. We wanted to rotate through people who we've had a good vibe with here on the show. And, of course, you've done 2.5 modules plus a wildcard episode with us. So we know that you're a good fit for the Coding 101 Army. So thank you for, filling in these shoes.
Yeah, you bet. Love the Coding Army. And, in fact, I love the Google Plus community. They ask some really amazing questions out there, too. So keep that up.
Yeah, they're good. Anytime you get a group of people who want to solve problems, that's always going to be fun. Speaking of solving problems, let's talk about a little something that involves your company. You're a senior software development lead over at Microsoft. And, let's talk about Microsoft making a bigger move into open source. This happened just last week. Now, Microsoft is acquiring a company called Revolution Analytics. That gives them a company that uses the R programming language. First, Lou, what is the R programming language?
So basically, it's a statistical library or a language that allows you to basically model data around for basically machine learning purposes. And so it's used by mostly, computer scientists, mathematicians right now. But Azure ML, which is Azure Machine Learning, it's at its core. So that's how you basically can build out models using the R programming language. And so this acquisition is huge because Revolution Analytics is a wrapper around the programming language to make it even more effective.
Right. We should note that R is an open source language. So this is in essence Microsoft betting again big on open source. But I got to ask, why do we need an entirely new programming language for, let's call it by its buzz name, big data? This is a big data company. Why can't I use one of the existing languages to do the same things?
It's a good question. So the way that R actually models languages today is different. It does it in more of a set-based analysis. So it can basically determine sets of data that meet specific criteria. And so the way that it's more of a closely related to a functional programming language than it is really a standard static programming language. So that's why it's a little bit better for doing that. Actually, it's a lot better for doing modeling large sets of data.
Right. It's what it reminds me of? It reminds me of Fortran. Fortran it's an old language. It was around when I first started programming, and it's great for mathematicians. Mathematicians love Fortran because it's closer to the way that they actually do problems. Is that the same kind of idea with R? I mean, yeah, you might be able to do big data analytics with something like C#, but it would mean that you're using incredibly large registers, and you'd be hacking a lot of the language in order to deal with such big data sets.
Yeah, I mean, R has built-in algorithms specifically for large sets of data, whereas C++, you have to acquire these functions and algorithms from somewhere else. And so, but R basically has it all built in. So, and there's lots of extensions on R that even make it even more possible to use against specific types of models. So like, specific types of data structures and data sets. So, I mean, it's rudimentally made specifically for big data.
Right, right. Let's talk a little bit higher level. We've seen Microsoft make these moves over the last year, and they've made a lot of moves towards open source, up to the point where they actually open sourced part of the .NET library. Where do you see this going? Because we're seeing more and more that Microsoft is turning into a services company, and so holding on tight control of all those old mainstay products doesn't seem as important. But where could this ultimately bring them?
Well, I mean, like I said, Azure ML, which is Windows Azure, I mean, Microsoft Azure is a big service, obviously, that Microsoft's been putting a big bet in. And so they have now a new beta for, which is called Azure ML. And it basically allows you to build out models around large, huge, massive data sets. And the data can come from anywhere. It can come from databases. It can come from the cloud data storage. It can come from pretty much anywhere. And you could feed this data into these ML models, which are, you use the R programming language to actually build out the models and support the, matrix analysis and so on. And then you apply these models, and then Azure ML can actually develop it works in machine learning, different type of machine learning algorithms to actually make sense of your data. And so they're putting a huge bet into this, and that's why they made this language open source. They use this open source language and the new acquisition to open source, because they want to push that, because that's such a huge thing nowadays to tackle, is making sense out of massive amounts, millions and millions of customer data, or billions of dollars worth of data that they need to make sense out of it all.
Okay, last question, Lou, and this one's a big serious one, and that is, what are the chances that Microsoft will open source the HoloLens? Because I really want to get a set of that. By the way, when will that be available? For people who have been under a rock, HoloLens is the brand new AR product, augmented reality from Microsoft, that looks phenomenal. And I want to know when I can program for it, and I want to know when I can get a set to put on my face.
So, I mean, to be honest with you, we had like a question and answer session today with Satya, and although I'm not allowed to divulge any information from that discussion, what I do know is, a lot of people asked about, will there be an SDK or a development platform for it? And I'm pretty sure that there's going to be something coming out. Who knows if it's around the release time or not, but they're still saying spring for the release time of it.
Show title, We Just Got Lou Fired. Now, Lou, when we come back, we're actually bringing Steve Gibson back onto the show. We wanted to do something a little bit different. This isn't a wild card episode, but it's not a hard coding episode. He is, as we all know, a big proponent of assembly. It's a very low-level language, and he wanted to let us into the philosophy of assembly, to let us know why he still uses that language, why he still thinks it's incredibly efficient, and why he thinks it has allowed him to build up a foundation in programming. But before we do that, let's go ahead and take a moment to thank the first sponsor of Coding 101. It's HipChat. Now, there are a lot of different ways to communicate in business today. There's phone, there's email, there's IM. You could tweet somebody. I mean, all of the communications revolution from the past 10 years has been about bringing your teams together. But the question is not whether or not your team can communicate, it's whether or not they can communicate efficiently, whether or not they can reach back into the history of the communications to find the genesis of a particular idea or the thought that leads to success. That's exactly what HipChat Plus does. Now, how is your team communicating right now? Go ahead and think about that. Are they using that variety of email, IM, texting, cloud storage tools, along with document sharing tools and maybe an occasional video conference? Or are they going to use HipChat Plus and put all of those in one place, designed specifically for your business? HipChat Plus is IM, it's video chat, it's document sharing, it's screen sharing, it's system updates, and, especially for our programmers, is code sharing integrated into one simple platform. Email is too slow, meetings get sidetracked, and regular IM doesn't work well for groups. But HipChat Plus keeps your team in sync, and it works from any device, no matter where you are. The best part? HipChat integrates with the top developer tools like GitHub, Jira, Zendesk, and more. You can go to their website and check out the 57 services that HipChat plays nice with. It brings your entire project and team communications together in one place. HipChat is easy to set up, it's fun to use, and it makes your team wildly productive. We use it here at the Twit TV Brick House to make sure that we're always on the same page. And whenever we have an issue or whenever we need to figure out why something happened, we could always scroll back through time and see where the communications leads us. Get your team on the same page in seconds. I want you to try HipChat Plus for free. No credit card is required. Visit hipchat.com/C101. Click on Start Chatting to sign up, then invite a few team members, and all the features are free for 30 days. After the free trial, you can always stick with the freemium version. Remember, that's hipchat.com/C101. HipChat, your team, your project in sync instantly. And we thank HipChat for their support of Coding 101. Now is the part of the show that I really enjoy. It's when we get to introduce our guest expert, our code warrior. And as it was last week, this week, it's Mr. Steve Gibson from Gibson Research. Steve Gibson, thank you very much for coming back on.
Great to be with you guys.
Now, your appearance on our wildcard episode last week stirred up a lot of emotion within people. There were a lot of people who were saying, right on, foundations of programming. We got to go back and figure out why our tools work, because we've gotten to a point where if you take away a layer of abstraction, we're back in the dark ages. Tell me, is that what you hear a lot from people who are listening to your knowledge? Do they kind of sit back and awe and say, yeah, I actually don't know how my computer works?
I guess my feeling is, where I was coming from when we talked about that last week was noticing that educational systems which try to teach coding by skipping over building a foundation of understanding for what's going on all the way down to the machine, have a problem in that you end up with a programmer who can sort of solve things by rote or by formula or by cutting and pasting, but can run across problems that they just don't have the knowledge to solve, because there's potentially critical pieces of their understanding of how the system functions that are missing. Whereas if you have somebody who really does know where this came from, who really understands what's going on below, not only are they able to solve any problem that you give them, because with that understanding, there isn't anything beyond their grasp. But the other thing that I didn't mention is that they have a better ability to solve the problems efficiently. Because if you don't understand what you're asking the system to do, you can ask it to do things that are really difficult. That there are better approaches for solving the same problem, and you only get that from understanding, what. For example, in a higher level language, it's easy to express something that is very hard for the computer to do. If you design your solution with difficult for the processor to achieve requirements, you're going to end up with an inefficient result. Whereas if you design your solution with the way the system actually functions in mind, then what the system actually ends up doing, it's able to do easily.
Steve, let me go ahead and ask this now. That is, what does assembly do? I mean, I remember assembly from my college days. I remember trying to get away from it as fast as possible. I didn't have a mind for it. I wasn't very good at it. When we talk about a low-level language, how is that different from C# or any of the new languages that we might have?
Okay, so one of the neatest things about the language C is that it was originally designed by some really smart guys back at AT&T who had written their first version of Unix in assembler. What assembler is a sort of a direct. I'm trying not to use the word mnemonic because that's sort of undefined until we explain it. It's a direct expression of the individual instructions that the hardware executes. So, for example, you don't have, you can't say A plus B equals C. you have to load a location in memory that contains the current value of A into a register. Then you need to add the location of memory that contains the current value of B to that register. And then you need to store the current, the result into the location of memory where you want the result to be, which in a higher level language you just label as C. So the point is that you're breaking down the much more easily and generally stated thing you want into the actual steps that the hardware, the microprocessor takes in order to achieve that. Now, it seems like a dumb thing to do. That is like, wait a minute, if I can say A plus B equals C, why wouldn't I rather say that? The reason is that a lot is lost in translation. And there are people who argue that, oh, no, today's compilers are so efficient, nothing much is lost. Well, it's just not true. The fact is, today's processors are so fast and memory is so vast that I wouldn't argue that there's no reason for assembly. I program an assembler not because it's faster or it's easier, but because it's what I like. It's like the classic, I mean, the question, what's the best language to program in? Well, it is the case that there are special purpose languages that excel at specific sorts of problems. But putting that aside, the answer to what is the best language is normally the one you like the best, the one you want to use, the one you're most comfortable in. So it's like if you're Randall Schwartz and you know Perl like nobody else's business, then you can probably solve a problem in Perl almost instantly because Perl is so crazy and powerful. Whereas if I were to solve the same problem, actually Perl is my alternative language to assembler because I want to go sort of to opposite ends of the spectrum. But it's often the case that I just enjoy using assembly language. I came from hardware. I was wiring and designing computers before we had chips and like building computers out of relays. So I understand where it came from. And I just never decided that I wanted to do something else. But I mentioned C in the beginning. C, the original C language, is really nicely designed because those guys understood that they wanted to create a language which was still very close to the hardware. And C is very close to the hardware. It's a powerful and fast language that I think makes a lot of just exactly the right sets of trade-offs. At the same time, it's got a very powerful pointer structure, so you can get yourself in trouble easily if you don't understand, what you're really doing.
All right. Let me ask Lou a little bit about that. Lou, you program for a living, obviously. Your choice is going to be Microsoft tools. What about that? I want to go back to that question that Steve answered in the middle of that segment there, and that was there are always going to be people. In fact, we got a lot of email after Steve's last appearance on Coding 101 that assembly was just silly now. It's moot. There's no reason to use it because modern compilers, and actually a few of them use the example of Visual Studio, will create code that is far more efficient than you could ever make in assembly. Does that sound right to you?
Not necessarily. There's a lot of programmers, even here at Microsoft. There's a famous one by the name of Raymond Chen, and he's an old Windows programmer that's been around for a long time, and he swears by the assembly language. He will write inline assembly in his C code because the compiler can handle inline assembly, and it will literally. He swears that it's better, and that's the reason is because he like Steve said, is he just knows that he's more efficient in writing that, and he could probably write more efficient code updating the registers and the stack on the CPU than the compiler can, because he knows the tricks, the trade, and the compiler doesn't necessarily know all of them. But on the other side, on the other camp of things is, yes, compilers and assemblers and linkers are getting better to the point where now, depending on what platform and what CPU type you're on, it can optimize the code better than potentially somebody can write it in assembly themselves, unless you're like your wizard, like Steve. I mean, if you're a wizard like Steve has been doing it for such a long time, you know all the tricks of the trade, and you don't necessarily have to worry about a compiler doing it for you. But if you're just learning, and sometimes you need to know the tricks. Sometimes using a really efficient compiler and then looking at the assembly or the machine code that it actually dumps out, and comparing that to what you're writing actually sometimes helps you learn too. So I mean, it's all dependent on what where you're coming from and how much experience you have.
Right. Steve,
and I'll just say that one way I might sort of rephrase that question is, it sounded like that the person who asked it might have been implying, or maybe I'm reading more into it, that in a higher level language, you can sometimes get you can write a more complex and better solution because you don't have to spend all your time at the lower level. That is, it's clear that anything you can do in a higher level language, I can do in assembler, because the higher level language compiles into assembler. So by definition, anything you can write. But there are things I would never want to write in assembler, because I'd just lose my mind, because they're just, so there is absolutely a place for a compiler, that is for a higher level expression or type of expressibility. Look at regular expressions, for example. I don't ever want to have to write a regex parser in assembler. They already exist. So it's like, I don't want to do that. And the other thing I would say is that when I'm writing, I write a lot of code for Windows. It's actually the case that most of my code is a script calling the Windows API. That is, my code spends most of its time in Windows. That is, in the API calls, and basically I'm stitching those together with assembly language. So it's not as if I'm writing to the bare metal, for example, SpinRite, where there is no OS underneath. In a contemporary environment, most of what's going on is you just calling the operating system and asking it to do things for you. I just prefer to make that scripting in assembly language.
Steve, we got a question from the chat room for you from Dallas, who wants to know if assembly has any place in web programming.
It's certainly server side, but also look at all the competition we have for client performance. Everybody's benchmarking, Chrome versus Firefox versus IE. Now client-side scripting performance has become crucial. And again, if you had to write a rendering engine or even a JavaScript parser in assembler, you'd just rather shoot yourself, because they are so complicated that you need the aid of a higher level language to sort of buffer you from needing to deal with all the details. On the other hand, if you did write one in assembler, it would blow the doors off of everything else for the rest of time.
Okay, we've gone 20 minutes in and we haven't actually seen any assembly code. So I'm actually going to pull a little something up. I'm hoping that it will lead us into you explaining why this actually works. Because the first time people see assembly, it does blow a lot of heads. Go ahead and, Brian, go to my screen. I did not write this. This is something I got straight off of Wikipedia. This is a sample of code for an x86 assembly. So Steve, this should start looking familiar. This is the first one that actually gets executed. Org 100H. I remember this with a passion. I hated this with a passion. What is this doing?
Okay, so I can read that. That's just English to me.
Translate it for us, please.
Completely comfortable. So at the chip level, remember I was talking about memory locations. So memory locations can store in a so-called well, there are many different architecture names, but the architecture that has generally won the war is where instructions and data occupy the same space. So you have locations in memory that contain data, and also locations in memory that contain instructions. So what that org 100H says is you're telling the assembler that the following instruction, which is that move 3, the value 3 into the AX register, you're telling it start assembling the program from location 100 hex. So that the opcode, the operation code, which is move, MOV, is a shorthand for some random hex. And I don't even know what that is. I mean, if I had to, I could look it up. But, I program at that level where I know that move means copy what's on the right-hand side of the expression, that's the number 3, into what's on the left-hand side, which in this case is the AX, is one of a number of registers in the chip itself, which are different from memory. Memory is outside the chip. Registers are inside the chip. And the reason is it's time-consuming to go and fetch things from outside the chip into the chip, or to store them outside the chip. So you have on-chip registers where you can work with the data much faster. And so, and actually, this little sample is a perfect example of what I was just saying, where we're moving a 3 into the register AX. Then that next instruction is a so-called software interrupt. We're saying generate a software interrupt number 10 hex. 10 hex is a call to the original PC BIOS for video functions, and where the value that's in the AX register when that call is made tells the BIOS, the 10 hex BIOS functions, what to do. And in this case, it says place the screen into 80 by 25 16 color text mode, which basically says how should a region of memory be displayed to the user.
Steve, it's okay. Let's describe these registries a bit more, because I actually grew up at a time where the very first hardware I got my hands on, because I was a dumpster diver, were these old computers where I could load 1 byte at a time. I had switches, so I would flip the switch to make it do the instructions, and then I had an execute button, and the execute button would take all those switches and turn it into something that would happen. That's essentially what we're doing with assembly, right? And that's the idea of the registry. I load something into the registry, and then when I hit the interrupt, it says, okay, run that.
Yes, the original computers were like those ones, those 3 panels I have behind me. They're sometimes called, blinking lights or switches and lights. And the idea was that an instruction back originally generally had a fixed length, that it was always 12 bits, for example, in the case of those PDP-8s that I have behind me. That was the first famous mini computer that Digital Equipment Corporation made. And so that 12 bits had 3 bits on the highest, the most significant 3 bits were the so-called opcode, something like load, store, add, jump, and so forth. And because you had 3 bits, you had a total of 8 opcodes, only 8 different things it could do. And then the balance of those bits of the 12, because it had a 12-bit instruction, that was the argument. For example, if it was a load instruction, then the rest of the bits would say load from where. If it was a store instruction, then it would be store to where, and so forth. So the idea was that the actual bits in memory were read one by one by the hardware of the processor, and it would look at the bits and figure out what to do. Then it would do that, and then unless it was a jump instruction, the program counter would increment by 1 to point to the next location in memory, and then the computer would get those bits and decide what to do next.
You know, the marvelous thing about assembly is you just told us what the move command does. So the move command takes something on the right-hand side and it moves it into the register.
Left-hand side.
On the left-hand side and moves it into the register indicated.
Yeah, I was careful to say it takes what's on the right side and moves it to what's on the left side, because you could have two registers. You could have AX, comma BX, or you could have a memory location, comma AX, in which case AX would be the contents of the register AX would be stored essentially into the location in over on the left. So, for example, the Intel, and this is Intel code we were looking at, it doesn't have an explicit load and store. It has a move, and whether you're loading or storing is implied by what's on the left and right sides, the source and destination, essentially.
So what's the difference between? I'm sorry, Lou, go ahead.
I was just saying, Steve. Each register has a specific meaning too, right? They do something very specific when you're storing data in those registers.
Yeah, it's funky. That the original designers gave some of the registers special powers. For example, they can be used sort of as general purpose registers. They're in the original 8088 chip. There's A, B, C, and D, AX, BX, CX, and DX. But for example, there is an instruction called loop, which is used for iteration. And it always uses the value in the CX register, which it decrements. And if it did not decrement to 0, that is, if it's not done looping, then that instruction jumps back up to a certain location. Back then, memory was very expensive. So if the loop instruction didn't imply what register to use, then you'd have to specify it, like loop on CX. But that would have taken up more space. So the designers said, let's just make the loop instruction assume or imply the CX register, because that'll save, a few bits. And back then, bits were expensive.
Steve, looking back at this code, how much of assembly is moving things into registers? Because looking at this program is actually Hello World. So this is the basic program that you would get. I move these, which I'm assuming are just those are characters, into these registries, registers. So H into this, E into that register, L into that register, and then somewhere along the line, I'm going to have an instruction to output that the screen. But how much is this essentially what I'm doing when I'm doing assembly? Just this over and over again?
Sort of. I'm wishing that I had given you beforehand a link to some of my assembly code. It'd be just perfect to show it. I have a chunk of it. I just wrote a really nice binary search about a year ago for looking up the contents of string values. There it is. Okay, so it's www. Can you bring up a URL? www.grc.com/misc files, MISCFILES/binarysearch.png.
There you go.
And that's what my code looks like. So you can see that it doesn't It doesn't look like a string of opcodes running down the left-hand edge of the screen. I also use all Microsoft tools. That's MASM, which is Microsoft's assembler. And notice that it says while EAX less than or equal to, I can't quite read that. Is it ECX? So you can see that this is very legible. I use meaningful variable names like target, for example, and some of my other little things like have, HALVEDX. Okay, that's not actually an instruction. That's a macro that I wrote, which shifts EDX right by 1. But what I'm actually wanting to convey is that I'm dividing it in 2. So I use my own macro says have to say that's why instead of saying shift right, there is an instruction SHR EDX comma 1, but that's not as clear. It's not as obvious why I would be doing that. Here, by saying have, it's much more clear. And look at that: if, else, and end if. So those are higher. Those are higher level.
I didn't know you could do that.
Yes, it's why I love programming in assembler. It's higher level structures in assembler, and what's beautiful about MASM, it's zero overhead. That is, that if instruction exactly evaluates to one opcode, one instruction. So there's no penalty. I wouldn't use it if there was a penalty. There's no penalty to expressing it that way. But look how much more readable that is.
Oh, yeah.
And so my point is, it is possible to code beautifully in assembly language and have absolutely no cost in terms of overhead in size or in performance.
That's amazing. That was completely unknown. I had never used MASM before. Now I really want to check it out because, yeah, those little bits of higher level programming take out so much of the grunt work because now I'm just worried about logic.
Well, for example, one of the things you have to do if you don't have this kind of flow control is you have to have what's called branch targets. You have to have a label to jump to, even if you really don't want one. It's like if I have 2 blocks of code, I want to say if this, else this. I don't want to have to say if this, then jump to something else, and at the end of the code I don't go to, jump around the other stuff. You end up having to create these temporary labels, and then it's like, okay, what am I going to call this thing that I really don't want to name? I just want to execute this block or that block. And so MASM allows you to do that. And so it makes for beautiful code.
Steve, when we come back, we got to have a little bit of a wrap-up session because we do need to move on. But I want to leave people in a good place with assembly. Hopefully, they'll be able to get a copy of MASM from Lou. Lou, can you hook that up?
Yeah, man. Yeah, Visual Studio Express, just a C++ package project. You can actually start assembling using the MASM.
We'll talk about that in just a bit because I'm feeling there's a lot of burning brains in the audience right now. So let's take a break to thank the second sponsor of this episode of Coding 101, and it's the repository of all knowledge on the internet, also known as lynda.com. Now, what is lynda.com? It's the place where you go to find knowledge, and it's not just about computers and electronics. You can find business skills, you can find art skills, you can find courses on photography. It's a place to go where you need to improve yourself. That's just what lynda.com does. Now, they want to challenge you. They want to challenge you to kickstart your new year by learning something with a free 10-day trial. Lynda.com is used by millions of people around the world and has over 4,500 courses on topics like web development, photography, visual design, and business, as well as software training like Excel, WordPress, and Photoshop. All of the courses are taught by experts, and new courses are added to the site each week. And these courses are all done by experts in studio. So it's going to look good. It's going to sound good, which means you can concentrate on learning. What's your plan for 2015? Do you want to improve your job skills to ask your boss for a raise? Or do you want to make yourself more marketable to find a new job? Are you looking to explore a new hobby or maybe set new financial goals or find a better work-life balance? Lynda.com has something for everyone. Some of the courses that I recommend are XML Essential Training, Simple Android Development Tools, Understanding SSH, and the Foundations of Programming series, which has installments to teach you everything from the fundamentals of programming to working with databases, object-oriented design, and more. It's what we're talking about here, making sure you've got enough of the underlying knowledge so that programming actually makes sense. It's not something that you just do, it's something that you live. Now, I want you to try lynda.com. I want you to do something good for yourself in 2015. I want you to sign up for a free 10-day trial by visiting lynda.com/C101. With your membership, you'll get unlimited access to every course on lynda.com, including access on your iOS and Android devices, plus new courses as they're added each week. That's lynda.com/C101. lynda.com/C101. And try it free for 10 days. Go ahead. I challenge you to learn something new in 2015. And we thank Lynda for their support of Coding 101. Steve, we've now seen a little bit of bad code. We've now seen some of your code. And Lou, hopefully, in the doc, will be giving us some links so that people can go and get Microsoft Assembler with the Visual Studio so they could try it out for themselves. What would you say is key for them trying it without just becoming completely discouraged?
Okay, so there was something I was going to suggest. First of all, I use Microsoft tools. They're what I want to use. There's an interesting multi-platform project called PEP 8. I was meant to send you email about this to show it to you. It is available for Windows, Mac, and Linux. It is a synthetic CPU with a beautiful IDE interface, GUI, the works. If you just, it's over on code.google.com, PEP8-1, and I think it may be a perfect place for people to start. I don't think they have any screenshots of it, but there's a bunch of tutorial stuff, and it allows you in this very gentle sort of, I mean, it is used for teaching people how to code at the machine level, basically to explain machine level concepts of registers and caching and architectures and so forth. So I think that is a great place to start. Switching to, the real tool is certainly something you could do, but I would say that's more for, a production mode than for an educational mode. And I did spend some time poking around looking for, there are a number of emulators that only run under Windows, but I thought for this audience, and especially since, you're standing in front of a Mac, that having something that was multi-platform going forward made more sense.
Steve Gibson from grc.com. That's Gibson Research. We do actually have one more bit with you next week before we move into our embedded programming. Every time we start, I think we could get through a lot of material. Then I realize he's just unpacking everything, and I absolutely love it. So thank you so very much. Could you please tell the folks where they can find you? Because of course, they're going to have to pick up SpinRite. I will say this, I'm not getting paid for this. My network doesn't get paid for this, but SpinRite has saved my butt more than once. If you have a computer, if it has a disk, be it a rotating disk or an SSD, and you don't have SpinRite in your toolbox, I just don't understand what you're doing with your life. Could you talk a little bit about another project that you've been working on a lot? You've got Squirrel coming up. Where can they find information about that?
Okay, so Squirrel, SQRL, is an acronym for Secure, Quick, Reliable Login. If you just put it into Google, Google will find it. Or you can go grc.com/SQRL. The demo is now up and running. So if you went to grc.com/SQRL/demo, it would take you to a page that would be a little confusing at first because you have to have a client. I have written a client, but we're still in the process of smoothing off the rough edges. But for example, click that down there below, Father, and you'll see what happened is it noticed that you don't yet have a session ID assigned just for the demo.
Okay.
So if you refresh the page or you click that, which does the same thing, now you'll see a traditional username and password login and a QR code. If you had a Squirrel client, and they're underway now for iOS and Android, Windows Phone, and I've written one for the Windows platform itself, and it'll run under Wine for the Mac or Linux, you would simply click the mouse on that QR code and you'd be logged in. It basically, it's a very simple and straightforward system that gives it, basically the idea is it will replace usernames and passwords on the internet. It sounds like, a big deal, and it's why I've given it the last 15 months of my life, is that even if it doesn't get adopted, I had to create it to give it a chance, because a user creates one ID once and then they can use that same ID potentially for the rest of their life on every site they visit. Every site sees a different token, so there's no tracking among people. And it really can replace username and password login. On Vimeo is a presentation I gave last November. That's a great place to start if anyone's curious. I'm not sure how you would find it, and I don't have any links to it yet. I've just been so busy coding. My, keeping up with the housekeeping has fallen behind, but I'll be pulling everything together here soon.
Fantastic. That's Steve Gibson, grc.com. Go there. And also follow him on Twitter. That's at SGGRSteve, Steve Gibson, GRC. Again, it's always a pleasure. It's always an honor. We'll see you next week, where I actually want to get some of your assembly code, because it makes a whole lot more sense to me.
Thanks, Padre.
I also want to thank my guest co-host, Lou Maresca. Lou, we're going to try this out a lot more over the next couple of weeks. We're going to get the flow going, and of course, you've got your sombrero, so everything is good. But could you please tell the folks where they can find you and your work when you're not here on the Twit TV network?
You bet. You can find me on Twitter, LouMM, LOUMM. Also on About Me, LouMM as well. And of course, all my work that I do here at my day job at Microsoft is at crm.dynamics.com.
Gentlemen, thank you very much for an entertaining and informative foundational episode of Coding 101. And sirs, I salute you. Don't forget that even though this episode is over, you can find all of our episodes at our show page. Just go to twit.tv/code or Coding 101. They'll all go to the same place, and you'll find our entire back catalog. If you want to download our episodes, that you can find out what we did in the first module or the second module, or when we were talking about C# or PHP or Perl, you can find it all right there. If you want it on your device, we're going to make it easy, and also that's where you're going to find the show notes, including links to our GitHub or to zip files where you can download the actual assets from each show. If you want to program along with us, we make it as easy as possible. Also, don't forget that you can use that little drop-down menu to the side to get our episodes automatically downloaded into your device of choice, be it your iPad, your iPhone, your Android tablet, your Mac, your PC, your laptop, your desktop, whatever it is, will help you get your coding fix on. Also, don't forget that you can find us on Twitter, or find me on Twitter at twitter.com/PadreSJ. If you follow me, you'll find out who we're going to have on each episode of Coding 101, and also what we're going to be doing on the other shows I do here on the Twit TV network. That's twitter.com/PadreSJ. We also have a Google Plus group, as Lou Maresca mentioned at the start of the show. Just go to Google Plus and look for Coding 101. It's filled with geeks, beginners, intermediates, and expert programmers, people who can answer your questions, and people who can also challenge you so that you reach the next level of your code warrior dumb. Don't forget that we do the show live every Thursday at 1:30 p.m. Pacific time. Just go to live.twit.tv and you can watch our pre-show, our post-show, and everything in between. And as long as you're watching live, why not jump into the chat room at irc.twit.tv. You can see me pull questions from the chat room. You become part of the family, part of the show. Go ahead and be part of the live. Until next time, I'm Father Robert Balaser. And, oh, wait, I forgot to thank my TD, didn't I? Because he gets mad when I don't do that. Oh, Brian, can you
don't need to thank me.
Can you say a few words to the folks before we go away?
Well, I just started taking my first C++ class a couple weeks ago, and I'm hoping that I can trick you into doing some of my assignments on the show. So looking forward to that.
And you understand now that you probably should have taken assembly instead.
Yeah, actually, that was really fascinating. So I'm glad Steve came on and talked about that.
Well, because there's no hope for good Mr. Cranky Hippo, end of line.